Morning, Alex. Morning, all. Can you hear me?
Hello, hello.
Hi, Alex.
Hi, guys.
Hey, John. Hey, hi, Jeff.
Hey, morning, guys.
I've logged in, but I don't seem to be able to take control of this. Anyway, okay, this should be okay. Right.
Yeah, there are like a million pop-up boxes trying to get in here.
Oh, really?
Yeah, with all these warnings.
Oh, yeah. It does that. Okay, let me just record the attendee. People a few more minutes. Okay. Looks like it's just the four of us, so hi guys. As you know, this is being recorded. So welcome to the OCP HPCM System Management workstream meeting. So today, sorry I wasn't on the, I know a couple of you jumped on a couple of weeks ago, and I wasn't there. Unfortunately, I had a clash and I think I was away actually, or in the air. So I did send out a note about cancelling it, but it looks like you must have missed it. Anyway, with regards, so to give everybody a bit of a catch up, if you weren't on the main call last week, basically with regards to this Oak Ridge National Labs New Frontiers RFP, we've been awaiting the final version of the RFP, which would be the kickoff for getting our formal responses in, and that they said that we would need to respond in 4 to 6 weeks. So we've obviously been given more and more time with that being delayed. They did announce just a couple of weeks ago that actually the RFP is currently on hold. From word of mouth, I've heard it's something to do with continuing resolutions. They said it will, it will resume. There's no hint of it just being completely cancelled. So I'm expecting it to still percolate through. It's just we don't know when at the moment. So I guess that's good and bad news. On the good news side, that gives us more time to get our proposal organised and together. Bad news is nothing like a deadline to concentrate the mind, which we don't have now. So, anyway, I guess what I really wanted to do was try and make some progress in the specific sections of each of the documents in terms of what we're actually going to do. Interestingly, I think the three of you are probably ones that can shape at least the structure of what we say here, in terms of making it compelling from the customer's perspective, in terms of, you know, this open system management architecture for HPC, which is consistent across all HPC machines going forward, rather than a grounds up effort every time a new machine gets delivered, as is the case, as I understand it today. So the extra time discussing with everybody actually has been quite productive. In fact, this week, on both the thermal work stream and on the interconnect work stream, have been quite good in terms of getting into some more deeper discussions. And that I think we're beginning to, I think individually these separate areas can be quite appealing to our RFP response, to give us a decent chance. So on the system management side, I guess what I've said is we're coming towards a very composable modular system, which needs to be managed more aggressively, I guess, in a regular delivered server, in terms of being able to discover what modules are all plugged in and how they're wired up, because they can be wired up anyway. There's not fixed configurations that the motherboard gives you, and discovering that, making sure everything's legal before maybe turning the machine on. Working with the root of trust and all the rest of it, but very modular. Each module being able to self-boot standalone is pretty critical in my mind, but then become part of this bigger machine, depending on what it's connected to. So system management, now obviously is John's the expert on all the lower level details, which we've had forever, and we don't want to throw away what's already been done, so we want to build on that. So on this, you know, effectively, I think Alex and John, you guys had a great conversation a month or so ago, with Alex's desires and challenges, and maybe John, you educated Alex on what's available today. So that was good. Where was I going? The other aspect of this is the hardware side of this. We do seem to be still stuck in the 70s with I2C buses and the rest, and it'll be nice to try and move forward more freshly and with new approaches, whilst we can't throw away the legacy completely yet. Anyway, so with that in mind, there's this desire to open up the hardware, as we've discussed. It's something called Libra BMC, where all of the RTL of the actual hardware is built in an FPGA and open sourced, unlike the closed sourced products that we get from the current BMC vendors. So Lattice systems have been built, or Libra BMC modules have been built with both Xilinx and Lattice. And Lattice, Munir is not on the call today, but Lattice are offering you know, their solution, and they have a good security path as well in their offering, which hopefully will come to the fore. And they've also brought together some tunneling protocols for a lot of the system management stuff called LTPI, the LVDS tunneling protocol interface, where you can carry all the I2C and DC signals around. So that's so fundamentally, we need to get the hardware infrastructure right and flexible on the modules. and then we need to make sure that we have a software layers on top. So the way I see it in this proposal is we would have in the system management section is we'd have the hardware piece and at least something along the software piece where we can actually get these to self-boot and become part of a bigger system. And we have necessary telemetry, etc., to be able to manage these systems when they're in operation and report things like the energy consumption, which is becoming a bigger piece of, because we have a sustainable and energy efficient focus, we want to certainly make sure we have parameters in the design of the system management to ensure that we can at least report the energy consumption by the various pieces of this machine. Anyway, I waffled on a little bit there, but that was just to set the scene. Jeffrey is, I just recently met Jeff on our main meeting a few weeks ago, and we had a long discussion yesterday. And I felt that Jeff's, he's with nVent, and he's involved in some of the higher levels of system management software. And as this is your first meeting, Jeff, maybe you can give yourself a brief introduction to Alex and John, and then they'll have an idea of what you do.
Absolutely. So it's a pleasure to join and meet you guys here virtually. I'm assuming most of the meetings here are all going to be virtually. But yeah, some of the stuff that we're working on over here is at Unify Point is around the, how do you manage the operations of all of these this infrastructure and hardware to the point where you're able to solve challenges before failures occur. And, especially for the HPC side, being able to go fix things before they fail enables you to get better utilization out of those assets and be able to handle more workload, more applications running on those machines where you don't have to continue to bring them to some level of a stoppage and then restart needs. So I've been in the system. I'm an old IT guy. Out of college, I integrated all of the infrastructure for all the companies Cisco was acquiring in the 1990s. And then I went on to Sun Microsystems. Briefly was doing acquisition M&A work for them, but I really enjoyed learning how to run a business and seeing how these product management roles worked over there. So I managed everything from servers to storage to flash portfolio, went through the Oracle acquisition, stayed on for a year and integrated with functionality into the database, the core database over there at Oracle, and then to help speed it up through flash capabilities. And then went ahead and went to Western Digital, started, selling products to all the hyperscalers, all of the big OEMs like HP, IBM, Dell, you name it, as well as kind of corporate America folks who were trying to go down the path of the way the hyperscalers were, right? Move away from the scale up systems and move into something more modern, some scale out stuff, right? But found they were telling me how bad they were struggling, and how difficult it was to manage all these systems. And basically they were throwing humans and hardware at the problem all the time, which doesn't scale at all, and is actually counterintuitive to to being able to solve problems. So that's when I was, found that Google was at a massive amount of scale. They had far fewer humans to machine ratio than anybody else, by around 2,000% less humans. Yet they were operating their infrastructure at a higher level of health. So kind of what I'm doing is going off and building those same tools that Google has. We were fortunate enough to have the guy who built this tool at Google, and all the data center technicians reported up to him. He's been one of our advisors. So he's been really helping us out. And validating, things like, architectures and and boy, did he ever save us a shit ton of time with some of the decisions we were looking to make, where we were looking at multiple different ways, and he goes, and he's like, yeah, don't do that. We failed at that miserably for these reasons. And so those things really saved us a lot of time. But yeah, we've built a product. We've got engagements going with the federal government, and contracts with the Air Force. Our product is built into, designed into solutions that IBM is taking into multi-billion-dollar government deals, as we're kind of one of the core functionality pieces of their solution. And so, was at the last meeting, was thinking that HPC's got a good opportunity as well, and use case for what we're doing. And so looking to help bring some of those capabilities into this solution and support the effort on on this new architecture of hardware that you guys are building. We think it's very interesting, and we think our product is, yeah, with every new hardware stuff, you got to do some testing and figure out if there's any nuances happening. However, we feel that, we'll be able to bring up a software solution that will be able to work across all this hardware fairly quickly, and be able to really automate the management of that infrastructure from an operational standpoint.
Thanks, Jeff.
Yeah.
Yeah, so Alex, from your experience with the HPC community, obviously you were saying the management software needs to be sort of rewritten every time. How do you manage historically? How have the labs managed with these massive 1,000-node machine, more than tens of 1,000-node machines, in terms of IT support for identifying when they're going down, or preventative maintenance, and all the rest, or is it you have 100 IT engineers for every machine?
I loved, so thanks for teeing up an easy question. Now I will continue to consume the rest of the hour answering it, because everything that Jeff was saying is stuff that is very key to what I'm doing as well. And Jeff, if you're interested, you should check out ochami.org, OCHAMI. That's the open source project that we're working on, and we're always looking for ways to partner on the basically do the same thing you're talking about, like bring some of the cloud scale to HPC. And more a direct answer to your question, the labs have people, lots of people, and they have people that are assigned per machine. So if you have we'll take, for example, we have I was talking to somebody who has a set of machines that were all bought around the same time. They were not all bought at the same time or on the same procurement, but they were all bought on around the same time. And so they all have the similar architecture. And 4 machines, 2 of them about 1,000 nodes, 2 of them about 500 nodes. All of them had their own team to keep them going and to make them run using the software that was provided by the vendor, which I don't actually remember. It might have even been XCAT. It was not one of the more modern things. And a mountain of Ansible scripts and Bash scripts and things like that get tested out on a test machine and then committed to a Git repository, and then that Git repository gets copied from one classification level to another with sanitization going on, and then they get applied. So you're doing it ends up being a lot of manual labor, all sorts of things. So yeah, Jeff, the industry needs some more standardization, needs to not reinvent the wheel, and needs to not be still thinking about a ratio like number of admins per server, because that, I don't know, that feels very 20,000 or 2003 to me, not 2024. So
No, it's I totally agree with what you're saying. We hear the same thing around hey, we've been writing scripts and scripts and scripts, and people have scripts running that those people have been gone for a long time, and then
Yep.
nobody knows what that thing's doing or who did it. And, we don't know if we could shut it off or, what value it's bringing. And, you just kind of run across it. But yeah, it's like spaghetti, right? And it's a piecemeal thing, and it's trying to find ways to actually solve problems, rather than collect a ton of data and not know anything about it. And that's the biggest challenge.
Yeah, and I think that becomes. I'll just add two more items. Like, so each of them have their own log storage format. Because and in some cases, job logs and metrics are stored alongside system metrics, and other times you have dedicated job storage for logs versus system storage for logs, following different paths, interfering with each other, sometimes being like duplicative to the point where you're actually storing the same log message in 4 different places. So that ends up being just a mountain to go through and try to understand, like, wait a second, am I seeing this message 4 times, or did I see this, did this thing happen once? Or did this happen 4 times, or did it did it not? Anyway,
Exactly.
I had a new one yesterday that is similar to this, where VMs actually make this problem harder, because in a time when you knew that, well, I deployed that piece of software on that node over there, you have a pretty good idea how much could possibly be running on one machine. But as soon as somebody puts a hypervisor in there, you can say, well, I know what's running on the machine. It's these 30 hypervisors, or these 30 VMs. Which of those VMs are still actually doing something? Hey, look, I've got Jira installed on all of them. I wonder which ones of those are necessary and which ones of those are not. And so you end up in this position where you're trying to do network tracing to figure out which VM is actually the one serving the Jira on this particular node. And so all of this ends up being challenging. So anyway, this is a digression from what we're talking about, but this is exactly the problem that I see. This is what I'm trying to solve in an open source way. And if there are ways that our open source can either provide modularity or standards, or we can find ways to collaborate, that would be amazing.
So Alex, we had a productive discussion last time regarding Redfish, and you mentioned the open source project that you're working on. Could you repeat that so I can
Yeah.
document its
So I'm
repository?
working on something called OpenShammy, which is a name that none of the people who came up with the name need to live with. But I do. And so I'll drop some links in the chat here. For those who are potentially interested, we're running our first developer summit, and we've decided to cast the net wide. It's going to be in Annapolis, Maryland in April. And if you are interested in attending either virtually or in person, we're going to be doing a lot of what are software standards, what are the agreements that we want all of the partners to have as they move forward. That kind of work is going to be going on there, and trying to decide what sort of a UI we care about. So shameless plug if you're interested in getting deeper on open source cloud like HPC System Management. Come to
Well, I didn't know.
Annapolis.
Sorry,
Go on,
Alan.
Joe. No, go ahead.
I know we had mentioned Redfish, and I sent a couple of links for it.
Yeah.
Did you spend any time looking at that, and would that help solve your problem?
It did and it didn't. I mean, so there's some really good standards on Redfish that, like, those were better when you gave me stuff about the composability manager. There was stuff that I had never read before about what was supposed to happen with the composability manager, which makes or the composability endpoint or something like that. A resource or composer
It was a
resource.
service.
That's it. I knew I was getting it wrong, but I couldn't remember why. So I think all of that seems like a really good move forward. I'm still nervous about extending Redfish to do these things, where Redfish being a hardware control, traditionally more of a hardware control library or a protocol. And once you get beyond the individual node, some of the Redfish abstractions make less sense to me. But this seems to be moving in the right direction. So I did learn some good stuff there.
So Alex, how long has OpenChammy been going? I'm taking a look. It's
Our first so we first started working in like July, August of last year.
okay.
We did our first demo of running software at supercomputing in Denver, and we're going to try to do another release, quote unquote release, in May for our Supercomputer Institute. So getting it really well documented so that we can get teams of interns to use it. People with no background in running systems need to know enough to know how to get DHCP running and why that matters and how HTTP boot is secured and things like that. So that should be in May. And then our goal by the end of this calendar year is to run a significantly sized system. And right now I've got my eye on 2,000 nodes that will be our
I saw
system.
University of Bristol when I was just glancing. Is that one of them?
So the team at University of Bristol just did the Isambard procurement.
That's right.
So the team that did that, they're looking at OpenShammy as something that they may want to write into future procurements because they want an open source something. They're also looking at how to add some additional functionality to the work that we're doing. So we've got CSES is doing a ton of work to show what multi-tenancy ought to look like. Lionel's just at this point stitching things together. And I think that Bristol wants to be on the forefront of running mixed workloads.
Excellent.
Well,
that's my hometown, so I have a particular passion for Bristol.
I'll probably be there. I'll probably be there in September. That's what we're talking. September, October. I might come visit. Okay. And then I think NERSC is really focused on actual cloud integration. And so what they're looking at today is trying to figure out how much of this control plane could be run as a SaaS in like, Google Cloud, and how much of it has to be run on premise, and what are the security implications and what are the performance implications of trying to span that gap.
Just based on what I was chatting with Jeff yesterday, just as if I can bring it down to the hardware nuts and bolts again, do you see this? I mean, it sounds like this is, you've got the very low level hardware and the old BMC. How much of this would actually do you see running in a BMC management processor versus running on the processor itself or across all the processors in the system?
So our preference is for everything to be out of band. One of the things that's on our wish list, although we don't know that we're going to be able to get there, is it looks like the hardware is getting closer and closer to be basically solving the problem of root having access to everything.
Right.
And so we would love to be in a position where our system allows someone with a job to bring in an encrypted VM which runs within a specially designed hypervisor on one of the compute nodes. And so the people who have root with access to all of the nodes don't have access to the running job and couldn't see them ever.
So when you say out of band, you mean still on the same processor, but just a separate?
No, I mean out of band, like over an I2C.
Oh, okay. Okay. So therefore, let me just bring the diagram up for Jeff's benefit.
Yeah. Hey guys. Unfortunately, I've got a call. I got to hop on right now, a customer meeting. But love where this discussion's going. Alex, I'll pump my email here into the chat.
Mm-hmm.
Would love to find time to connect with you.
Absolutely. That'd be great.
If you've got some time next week. Unfortunately, this week is crazy for me.
I'll be at the Energy HPC conference next week. Any chance you'll be there?
I'm not, no.
Okay. Well,
But if you
anytime.
find some time, you know, you need a break from all of that walking, you know, we could find time
Sure.
to schedule something.
Yeah.
I think there will be a lot to talk about because I think a lot of the stuff that you were talking about we have already, and I think you'll be surprised at some of the other stuff that we already have done as well. So
Great.
um,
Yeah.
I just shot that in there.
There it is. Okay, cool.
You, Sean, at your
I'll
point.
drop you a line.
Awesome. Looking forward to chatting with you more about it.
Cool.
Thanks for joining, Jeff.
All right. Thanks, guys. Have a good one.
Yeah, so if I'm of the same view that we want very sophisticated system management out of band and like a separate processor. And so and when you think about that, the current infrastructure, like you said, I2C is obviously 1970s vintage. We really need to move on from that, but equally we need to still support it where necessary. So you're familiar with this diagram, Alex and John?
You've shared it before, but I don't remember it.
Okay, all right.
I mean, I remember seeing it, but I'm trying to reparse it.
Yeah, and it's because you're on the software side, and we've, you know, it was probably before you came as well. So it might be worth me just reiterating what's going on here. So this is basically the, if you like, the BMC piece of the HPCM module. This is a hardware structure of the, as I see it at the moment, in terms of physical devices. So you know, it's like a traditional server motherboard's BMC. So I've got a couple of examples here. I was working with IBM on a module way back a couple of years ago, and so they were also helping me out on how they do it. But you've got your PCIe interface from your processor. You know, the 4 lanes typically. I think it's called, can't remember what they call the ePCIe, that connects your BMC to the processor. Then you've got the low pin count interface as well between the processor and a few other IOs. So that white bus there is basically connecting the sideband BMC to your main processor and or accelerator. So we need it to work for all different devices, obviously. So that's that. This is an FPGA from Lattice, and they're recommending that we go with the Avant E30. It's got a lot of hardware security built into this one as well. But effectively, it's an FPGA where you can implement soft processors and you know, or any particular hardware features. So you can actually you can build your exact management processor as you need in this device to replace a traditional ASPEED or whatever that normally controls all the hardware. This device is actually quite a sophisticated device. It's not and so it has PCI Gen 3, I believe, on it. I think you only need Gen 2 for these links to the processor. So this is really the heart of everything. They're also talking about this is a particular package where there'll be chiplets inside, so you'd actually have your memory inside, non-volatile memory, you know, for secure things, encryption keys, etc., and maybe even some SRAM and some DRAM inside as well for your processor memory. So you know, this is what they're proposing. It could be a Xilinx FPGA or anyone else's, and the idea is an open source root of open source, you know, that can be traced back security wise to the code is implemented in there. Then this is just a bit of the physical realities. So you've got obviously you've got the bus connection to the main processors or accelerators. but then you've got the I/O devices on the card. So we've got, if you remember the module, we've got basically 16 media sites that can also be I/O if you put cables in, but they're E3.S media generally. And they obviously have I2C buses and the normal sidebands that come with them. So these little ICE40s are tiny, tiny FPGA devices that actually aggregate the I2C signals, because we've got so many of these damn I2C signals with so many connectors that they it becomes a pain in the butt to manage. So Lattice have this single wire aggregator where it goes into it, puts all the sideband signals over a single wire. And that means that we don't have a massive I/O controller at the front here. So you're bringing 2 sets of sidebands from here and 3 sets of sidebands from these ones where you've got the bigger NIC 3.0 interconnect. And you can also expand to monitor power sequencing, power monitoring circuits, certainly as we do more and more power monitoring in the card itself. So that basically brings everything into this one processor. These are the topology interconnects, if you remember on the module, where we actually connect the modules together. These are 8 lanes PCIe or Ethernet or whatever. And what we've said there is in the interconnect work group, we're trying to make these into a universal interconnect. So you could cable anything. You could cable NVLink, Infinity Fabric, UPI from Intel, SMP from IBM, Ethernet, CXL PCIe, etc., or any proprietary ones from anyone else. It's just that everybody uses the same mechanical and electrical interconnect. Actually, guys, I just need to let my cleaner in. Can I leave you two to chat for a couple of minutes while I run down and get her?
Sure.
Okay, cheers. Thanks. On my way then.
Alex, I had posted a question on the chat. So what does Open Jammy use now to connect to the remote node out of band?
So our preference is Redfish. In fact, some of the hardware that we've been given doesn't support Redfish directly, or actually if we try to make a Redfish request to the BMC, it tells us, it responds, but tells us to go away. And we have not figured out any combination of authentication and just URLs that will ever work on that device. So we think that it was just stubbed out and we don't have access to the firmware. So we're actually not going to implement IPMI or any of the other or anything else. We want this to be a Redfish first, Redfish only for hardware discovery. And we will fall back to a discovery image where necessary for devices that can't do Redfish.
Okay, so wish I could get you into our lab, because we have a number of Redfish systems in our Redfish interop lab that we use for just this level of testing to make sure every node acts the same.
So we have a piece of software that we have written that is called Magellan, that its entire job is just to reach out and try to try to walk the Redfish tree of components, and figure out what's in a particular, what's accessed by a particular device. And so I was going to say node, but I mean, we use this for chassis level stuff. We use this for cabinet level stuff. We use this for anything that can be represented as a Redfish object. At the moment, we've only been working with 3 different BMCs that all behave similarly. And so that hasn't been too crazy. But my background working with Redfish is that, I think I may have mentioned this before, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is a perfectly valid serial number for Redfish. And if all your devices report the same serial number, there's no conflict. Yet that's incredibly not useful to us for knowing what the serial number is of a device.
Right. because we depend on the implementer to
Right.
report distinct serial numbers, right? That's
Right. And if they choose not to, they still pass validation on an individual BMC level, but then the whole system becomes not useful. And we've lodged some complaints with vendors.
okay.
Hi, guys. Sorry.
I'm trying to figure out if you file that with the Redfish forum, can they go fix the test? Because in the Redfish service test, they may be able to make sure that the serial numbers are unique. Huh.
Oh, it never occurred to me that that might be something that you could do validation testing for.
Yes, yeah,
But yeah,
well,
maybe
but
it's not a.
yes, because most people think of Redfish as a testing a interface for a single node, right? If Redfish was meant for managing multiple nodes across the entire group of systems, so it's easy to write a higher level test which says, hey, if you have more than one system, they better have different serial numbers, right?
Right.
Or you're just punking me, right?
Right. Exactly. So yeah, I'll go back and find some of the other things that we found
Mhm.
on devices that claim to be redfish
Right,
that were weird.
right.
Um,
So
yeah, yeah,
so do you work for Los Alamos? Is
I
that
do.
okay? So Los Alamos may have a academic alliance relationship with the DMTF, in which case they could have more privileged access to the Redfish forum, because we value all this all this information coming in. Most people are companies, right? So we have a special section for academic alliances, which cover academia and research institutes like Los Alamos. Um, Second is that you also mentioned concerns about Redfish extensibility to cover, software aspects. And I think I mentioned to you that we didn't go there. We started hardware because that's the point of least contention, and we've actually been dragged up there by OPAF, which is the Open Process Automation Forum,
Mhm.
and they extended Redfish themselves and said, "Hey, we need about OSs, containers, and virtual
Yeah.
machines. So here's our extension. Um, here we contributed to Redfish Forum. You guys go standardize it." And so we did. But it's a very low level. This is all they wanted to care about. Identification, see if it's still running, that stuff. And we said, fine, we'll add that. And this is our stake in the ground that Redfish has no problem going up there. We just have no expertise in the room for us to
That's
legitimately go up there, right? And so if you would come in and say, hey, I just need it extended to do this, so I can generically do more stuff, then I would greatly encourage you to contribute whatever requirements you have to the Redfish forum, and we can launch an OS/VM task force to go extend it in that direction.
well. So I guess I'll find out who our representatives are and what our license looks like for DMTF because I would love to be part of the forum. But this was one of the things that came up when I was talking at the Open Compute Platform Summit in Santa Clara this year was about Open Rack Manager and where Open Rack Manager sits as an OCP project with an API that should it become more like should it become more Redfish, and should it work towards Redfish resources, or do we want to find another place for it and then make sure that the integrations with Redfish are really, really clear and really good? And so that's where what I'm left with is this. I feel like Redfish does a great job at hardware management. I'm not sure it's the right place for software management. And I think that when we ask it to do software management, it does feel unnatural. And if we want to make it feel natural, we need to like kind of have some further thoughts about this because it's also true that I'm not sure I want the same thing that is doing my um let's say, cooled water loop, understanding exactly what the kernel version is of a particular VM which is running on a hypervisor. I feel like those might be operating at different levels of abstraction and perhaps not ideal to put together. But I would love to be part of that discussion.
I'm back, by the way, guys.
Oh, welcome back.
Yeah, sorry about that. Sounds like you're having a good discussion there.
I think we should have a really a separate conversation about this because I think we're moving in that direction pretty quickly. In that we have a software agent running on the OS, exposing a redfish interface to deal with all that level of abstraction. And then we have a redfish agent inside the BMC dealing with all the hardware abstraction stuff. So
yeah, I would love to. So I'm trying to track down. I just sent a message to try to track down my DMTF representatives because this is exactly. I would love to talk about this. Consider me an enthusiastic but skeptical partner.
Right. And so with the rack manager, it is coming out with a redfish interface. And that redfish interface is being tested against all the conformance tests that redfish form has. Right? So,
Yep.
Okay.
Okay, now this is all good stuff. So yeah, I guess you're trying to raise the bar, Alex, and of management level, and I guess Jeff, who we just introduced to, is even higher level again, trying to do the diagnostics automatically rather than just report all the results to somebody to work out what's going on. So I mean, it sounds like we have all layers from a software perspective, at least in the room with you guys. So that I like that. Go on.
Can I ask 2 questions about this slide?
Yeah.
So the controller there,
Yes.
BMC, are you thinking that will have an embedded TPU, or will there be a discrete TPU which is accessed by that controller?
Right. So when you say a TPU, what do you mean by TPU?
So the actual like hardware root of trust for the device
now this isn't my skill domain, but my current view on this or understanding is you have like the DCSCM, which is a singular root of trust that everybody reports back to. Each of these devices, Lattice have a tremendous amount of security expertise, including the PUF stuff, the physically unclonable stuff that you put into these devices, and the secure management side of it. So there is the potential that this could become a full root of trust device as well. I'm not sure exactly how people are planning to do this, whether there's one root of trust that everybody reports to and signs into. But storing keys and all of that would be all managed in here, yes.
Okay. So the benefit, so my experience with a discrete TPU, which is my understanding of the SDSCM from OCP, is that you need a fusible chip. I'm going to get this wrong, but that will allow attestation of cryptographic material without exposing the key it's using.
That's right. That's right. So this has that sort of feature. It has.
So that would be a piece inside the BMC controller, not something that is discrete and external.
It'll be inside the controller. It will also have on board a non-volatile memory. And it may be, they're talking about several chiplets inside this package. That's where they're wanting me to use this package. And so I'm not sure if it'd be in a separate chiplet or be in the same device as the processor, or a bit of a mix of the two.
Okay. Because what I'm thinking about is, and this becomes the next chain in verification. Because for all of this, the thing that I care about is how we do verification, that the things that the BMC is talking to are the things I want it to talk to and nothing else.
Yes, right, exactly.
So that's what I mean. So if there is a hardware way that we make sure that is possible, and then a software way that we then take advantage of it, then I'm happy.
Yeah,
Um,
so I'd imagine so like every E3, every SSD or memory module you plug in, for example, you've got the I2C bus there anyway, and one would assume you'd be able to tap into those serial number security communications would be what you could
So,
potentially do there.
so within the OCP security group, they're about to launch a device attestation workstream,
Yeah.
which is exactly that. How does the BMC attest to all the devices that happen to be on the platform, especially since now they're modularized, right? So
Right.
that the pieces you woke up with today may be different than the ones you woke up with yesterday. And how do you identify that? They're not the
Yeah,
same,
yeah. So
right? And I have to reattest everything to make sure
So
it's
the,
worth
the the opportunity here, guys, is we're specifying the hardware, and the nice thing about being an FPGA is it is extremely flexible. But obviously, things like does it have these various security requirement boxes ticked, etc., whatever they be, is another one. But the other thing I want to do with this, so what you see in this diagram is all of we're sort of bridging the old with the new. The topology interconnect actually doesn't have sideband. So if you're doing PCIe cables, you still have to carry all these damn sideband signals, like 11 of them or more. And with LTPI, you just put it over one differential pair that also the connector manufacturers like. So and it's a high speed. It's like it can go at a gigabit per second. So in our topology for this particular standard, we're just going with the native LTPI rather than a bunch of sidebands. Obviously, this could also be Ethernet where there is no sidebands. It's all carried over the transceivers. But so this is our approach. However, this still doesn't cater for where I see system management can go from a software perspective. If we're relying on communication between modules through these cables, if and when they get wired between each of the modules, it's a bit of a haphazard method. Now, we can discover it. I would much more prefer to have a systematic control plane in this, which is where the green arrows flying to the top left there from the device, they're representing a control plane. Now, you can see that what I'm showing those is optical I/O at 1 gigabit per second. And I've said there's 4 to 6 channels. Now, the reason for that is these modules, when we put them in the wall, if you remember, they go in the wall, we actually put them next to each other. So you get a mesh for free, if you see what I mean. So if you put a little optical free airspace transceiver, which is what I'm talking to people about, then when you plug modules in next to each other, they actually form a mesh without a physical connector. It's just a little optical link. So between the two devices. And then we have a large mesh control plane where all the system management communication can go between all of the modules. Does that make sense? Now the six would potentially could go through the wall to a module behind the other module and maybe even across the aisle to a module on the other side, but that's a little bit more of a stretch. Think of a minimum of 4 to give us a mesh for the system management bus. So it's a much more sophisticated system manager from a control plane perspective. Does that make sense?
It does, but so you're talking about the communication links, but I still am left with, how do I know that the thing on the other end of this communication link is the one I want to talk to, and that's the only thing on the other end of that link. There's nothing listening.
So, well, each of those links, like a bit like each of these, if we simplified the question you're asking to the media modules that are plugged in, as John said, somebody could unplug one of those overnight and plug a new one in. So you would have a secure communication with those modules, identifying who they are every time, a new module was plugged in. and negotiating before you have any communication with it, right? Identifying and passing keys, etc. So the same, in my mind, the same would happen for the links between the modules. It would be, and you'd start with a root. So we might actually build a dedicated root of trust module, for instance, which is the heart of the entire security management. And then it communicates with everybody else through these links, through the green links, and discovers everybody else and in a secure way. So it finds the first node next to it, has a security conversation with it, establish it's okay. That one has a security conversation with the media devices plugged in the processor that's there and says, yeah, here's the serial number of the processor, here's the keys exchanged with the processor, etc., and the media. Everybody gets said they're okay, and then it spawns out to the next module along, and you just carry on until you've done the entire
That's why I brought up the OCP security workstream to
Yeah.
do device attack.
Right,
Because
right.
that's
No,
all
the
the detail, all
DCS
the details will be done in there.
Right, exactly. So the DCSCM, if I understand it correctly, the security module is the root of trust module that you start with, and so and that then has to communicate. Now we have had discussions that one of these, if you can see my mouse, one of these media slots could be a DCSCM, but DCSCM as it's specified today doesn't fit in an E3 slot. But if we could easily make it fit in one of these slots. So one of these modules could have the DCSCM in it that starts the negotiation of security with the module it's plugged into and branches out to everyone else's module. Or somebody could say, no, we want a DCSCM in every one of these modules. You've got to have your own local DCSCM in. Okay, we plug one in for every one, whatever the security people want at the end of the day. But this Lattice device is absolutely going to have security built in. This is why Lattice are pointing me to this particular device.
Sure. But okay. So what I'm really getting at then is the Calyptra standard, which is part of what the security work stream is working on at OCP.
Okay.
And Calyptra is a way of attesting the firmware. It's a chip that does timings of firmware, and then all of those timings then get stored someplace, and you have to have a secure channel established to publish those timings.
DCSCM then, in my mind, that's a DCSCM if I understand that correctly.
I think you're probably right, but then all of the other things have to also implement the other part of that, which is doing the timings and sending the timings. And the Calyptra chip is the thing that is there. So that ends up becoming a dependency of anything that plugs into one of these slots.
Yeah,
They all
so
have to have.
Right, so I'm assuming either the communication would go over this control plane set of links back to that Calyptra chip, or if they said no, one Calyptra can only manage 10 devices.
No. Every device needs its own Calyptra chip, which will do the timings of the device, and then it will
device. So therefore, an SSD I buy off of Samsung will have to have a Calyptra chip in it.
Yeah, you see why I'm bringing this up as a thing. Now I know that when I talk to the folks at Azure, there's a period of time in the future where they're likely to require every single device that goes into Azure to have a Calyptra chip in it. So the likelihood that your Samsung SSD will have it is very high. It's also incredibly cheap.
I was going to say, but so it's an actual physical die that you have to integrate in.
Take a look at the link that I posted to chat.
Calyptra is from Microsoft, isn't it? Is that a security chip from Microsoft?
Microsoft is one of the participants, but it's Microsoft. I think Intel's involved. I know AMD is. I think Google was a part of it at one point. I'm not sure if they still are.
Okay, so what I'll do then is I'll get back to Lattice and I'll just double check that the security they put in here is Calyptra based.
And if not, then figuring out how to make sure that we're getting a similar level of security.
I guess to your point, Alex, is we have a clean sheet of paper here. So
sure.
we can actually on the heart. So what I want to do is we've got the nice thing with the three of you that were on the call today, including Jeff, is we seem to have a really good holistic picture of what we have today and what's missing and what we need from an HPC and a, you know, and a cloud perspective. And the entirety of the industry has been on 1970s technology for the last, you know, 40 years or more. And we, because it's a boring piece of our industry that nobody's interested in, it's never been advanced from a hardware perspective. So this is a once in a lifetime chance for us to upgrade the hardware in a revolutionary new idea of how to do this. And so this is perfect conversation for saying, well, if you're going to do this, make sure it's collector compiler. And also under OCP, we do have all these other efforts going on. Yeah. And so we can, you know, I can't pull everything in from the other one. And that's OCP open collaboration is, it can be challenging because, you know, everyone's got a slightly different optics on what they're doing. You look at Intel and Microsoft came to OCP with 19-inch racks, although OCP was 21-inch. You know, it was a case of, you know, so that wasn't very good for standardization, but they had good reason for doing it. Anyway, so I think trying to line things up, and if things don't line up easily, asking the question why they don't, and then seeing if we can get them resolved. But that's what I like about it. So in terms of this proposal to the DOE, we could capture all of this and say we're going to deal with everything in from a clean sheet approach, and then it can be far more elegant. It can keep the software people happy. It can keep the low-level hardware device management people happy, and, you know, keep everybody happy and be performant.
Cool. Yeah, I mean, so the reason I raise this is that when we get to the point where we are testing firmware, because at some point I'm going to want to have one, and this is, I think, something I brought up at a previous meeting, is I want to be able to give you a signed binary once it's been uploaded to all of the many devices that, like, if we've got 30 GPUs, I want all 30 GPUs to have this new firmware, and then I want to be able to attest that each one of them has it. The hardware has the capability to do that if we build in these pieces of security at the very lowest levels. But if we don't do that, then what we end up with is hardware that can give you a very confident lie, and you won't be able to tell the difference.
Right. Well, so we've run over the time, but essentially, again, I think on this week's been pretty good in the workstream meetings. We've had deep conversations about this. I think that if we can put a nice high-level description, and to be honest, Alex, I think you're in the best position to do this because you see all the angles. I think Jeff's probably too high level for some of the details. John's probably too low level for some of the other details, and you're nicely in the middle, seeing the problems from all directions. And also being an HPC guy, you know exactly what these guys in the labs talk. So I mean, I don't know if you could spare some cycles, but if we could get in this sideband management section of the proposal, we could articulate where we'd love the world to go. And with this is an opportunity with a clean sheet of paper from the hardware, the firmware, the software, and the high-level software. And then John and Jeff and myself, we can, and Munir from Lattice, we can then build around that to make it a very attractive proposition. And the only where I want to get to really is if we have a system integrator sat on top of all of us on these sub projects or these sub work streams, we get one bucket of money that we can distribute around everybody, and we can get a full working POC going. But if not, the government might say, hey, we really like that system management piece, and you've got a number on that piece of it. We're happy to fund that, but we're not happy to fund the rest, or we're happy to fund two pieces, or hopefully they're happy to fund the entire proposal. That's where I would like the proposal to be. Do you think you could maybe make a stab at putting a boilerplate in place in the document?
Yes, you're gonna have to resend me the link to the documents, but yes.
Okay, I'll do that, and I'll give you editor access.
Great.
Well, no, excellent. I really like the way this is going, and so just on this Calyptra stuff as well. Oh, sorry, Open Chami. I'm really quite interested in what you're up to there. So sorry, you mentioned the Energy HPC conference. Where is that, Alex?
It's Rice University in Houston.
Oh, that energy one. Yeah. I saw that. I was going to go to that. It's tomorrow, is it?
It's next week.
Next week. Okay. Yeah. Actually, I might see if I can get to that one. And the other thing you mentioned was
We're doing a developer summit in
Developer
Annapolis
Summit.
in April. Yeah.
April Developer Summit. All right. And that's Open Chami.
That's Open Chami, yeah.
Okay. Excellent. I'm not sure if I'll be able to make that. When in April is that?
It's April 9th and 10th, I think. The goal there is to spend time with a bunch of developers who are all wanting to contribute and try to get everybody agreeing to the same kind of like coding standards and testing standards and things like that. So
Okay, so it's a
not,
bit of a
not
low
yeah,
level.
not architecturally speaking, probably not a lot of feature development discussion. You're more than welcome, but it may not be what you're looking for.
Yeah. Okay. All right. No, that makes sense, Alex. Well, okay. Well, thanks, Alex. Thanks, John. I'll let you guys go, and good meeting.
Good to talk to you. Cheers.
Bye, guys.